In this video, I'm going to talk about CORS, which stands for Cross-Origin Resource Sharing. I'm going to cover three different things in this video. The first is what CORS is. The second are different kinds of failures or CORS failures that you might run into and how you can deal with them. And that'll be the bulk of the video, and this website here is meant to demonstrate those failures. And the third thing I'll cover briefly is why CORS. So what's the point of CORS? Why do we need it? First, let's talk about what CORS is. And in order to do that, it helps to talk about the same origin policy. So the same origin policy is a policy, or basically just a rule that browsers follow. And what it does is it prevents scripts loaded from one origin, like origina.com, from reading resources from a different origin, like originb.com. And in practice, what this looks like is if you have a script loaded from origina.com that contains this JavaScript, so fetch some resource from originb.com, then by default it will fail because the same origin policy prevents fetch from reading data from a different origin. If this script from origina.com tried to fetch data from the same origin, which is origina.com, then it would work. And so now we get to CORS. So what does CORS have to do with the same origin policy? Well, CORS basically lets you get around this policy. So it lets servers define origins that should be able to read their resources. So in our little example here, with CORS, origin B can basically say, hey, I actually want to let origina.com read my resources, in addition to originb.com. Now let's look at some examples of requests that result in CORS failures and some requests that don't. And the setup here is basically I have three different Express servers running on localhost on different ports. And these buttons, all they do is they send a request to one of those servers, and we'll be able to see what happens in the console and the network tab. So I think it'll be easiest to start with an example where CORS passes. So let's click this button and see what happens. And we can see that we posted to localhost 3002 and it was successful. And the key thing to note here is this access control allow origin response header. And this is basically saying that the server should allow requests from localhost port 3000, even though it's of a different origin. So basically this is saying, hey, don't apply the same origin policy to this origin and let those requests succeed. Now let's look at a failed request. So if we click this button here, we can see that the request failed. If you go to the console, let me clear that actually. If you go to the console, we can see that it says access to fetch has been blocked by CORS policy. And so what's going on here is that the key thing to note is the absence of the access control allow origin response header. So because that's not here, the same origin policy applies to this request. And this actually tells us that no access control allow origin header is present. So the same origin policy applies, and since we're making the request from a different origin, the request fails. Now let's look at what happens when you specify a mode of no CORS on the request. So what this looks like in code is you can see basically when you call fetch here, in the options, the mode will be no CORS. And that basically means, hey, this should succeed even if it violates the same origin policy. And so what happens is we click this, and we can see that, let me just clear this, we can see that, hey, yeah, the status of the request now is 200, even though the response doesn't have the access control allow origin header. The tricky thing to note here is that I'm logging the response, and we can see that the type is opaque. And opaque responses don't have a body. So basically what's happening is that even though the response comes back and the request appeared to be successful, we can't actually read the body of the response. It'll just be null. If you did actually kind of deal with CORS the right way, the body would not be null. As we can see here, the body, if you support CORS, is actually, well, it's a readable stream here, but it's actually some JSON. Alrighty, let's talk about CORS pre-flight. So I'm just going to click this button and we can see what happens. you can see that it looks like 2 requests are being sent. That's not actually what's happening, but I'll go over it in more detail. So this first request here, the first and only request, is called a CORS pre-flight request. And basically what the browser is doing is before sending the real request, which is a post request, it sends this pre-flight request to check whether or not the real request will pass CORS. And so we can see that this is a pre-flight request by looking at the request method. Its options, our real request is a post request. And we can see that the access control request method is post. So that's referring to the real request that we want to send. And so the way that the browser can determine that the real request won't actually pass CORS is because the response headers don't include access control allow origin. And so the browser doesn't even have to send the real request. It can just fail. So actually what happens is the browser doesn't even send that real request. And the rationale for this is if maybe the real request might result in modifying some kind of user data. Well, you don't want to do that unless the response will actually be able to be read by the browser. And if we look at the console, we can see that it tells us basically what I just went over. It says response to pre-flight request doesn't pass access control check, and this access control allow origin header is not present. And so you might be wondering why there is a pre-flight request for this request, but not for the first failure request that we sent. And the criteria here is basically, if we look at MDN, we can see that simple requests do not trigger a CORS pre-flight. And so this first request with this button is simple. The request sent via this button does not count as simple, and the reason is because I set the content type header to application XML. And that just means that based on the criteria, it is no longer a simple request, and thus it will result in a pre-flight request. So we just looked at a pre-flight failure. Now let's look at what happens when the pre-flight request passes. So if I click this button, we can see that there are 2 requests being sent. The first one here is the pre-flight request. Again, we can see that the request method is options. We can see that the access control request method is post. But this time, in the response headers, access control allow origin says localhost 3000. And there's some other CORS headers here as well. And so based on these headers, the browser knows, hey, if I send the real request, it won't fail because of CORS. And thus, the real request, which is here, it's the post request to our server, that will actually get sent. And just like the pre-flight request, the response headers include this access control allow origin header, which means that it can pass. So by now you might be thinking that you know everything you need to know about CORS. Well, before you stop watching, there's one more important thing to cover, and that's what happens when credentials are being sent to and from the server. And so before we actually click on this, let's look at the code behind it. So here we can see the request options for this button. There are 2 important things. First is credentials include, which means, hey, even if we're making a request to a server that has a different origin than us, include the credentials. So include things like cookies. And the second is a set cookie header, which just sets some arbitrary cookie. So now let's see what happens when we press this button. Let's go to the network tab. So the first thing to notice is that this looks a lot like the CORS pre-flight failure button. The reason for failing is different, but it's similar in that since we have a set cookie header, the request is no longer a simple request, and so a pre-flight request is sent. In this pre-flight request, you can see that there are some CORS headers. So why is this second request not being sent? And the console will tell us if we take a look. It says that the response to pre-flight request doesn't pass access control check. The value of the access control allow credentials header in the response is empty string, which must be true. And what this is saying is just that, hey, if you look at if you look at the response headers for the pre-flight response, it's missing a required header. So it's missing this access control allow credentials header. And the reason why it needs that is because we're setting the credentials mode to include. And so when that's the case, then we need this additional header to be sent by the server. Finally, let's look at an example where credentials are being sent, but CORS doesn't fail. So if we click this last button here, we can see that a pre-flight request is being sent, again because we are using the set cookie header. But this time in the response headers, we can see access control allow credentials is true, and that means that the real request succeeds. And again, we can see that this header here is set to true, and we can note that set cookie is pi. So we were able to successfully send a cookie to a server that has a different origin. To end this, let's talk briefly about why CORS. So what purpose does CORS serve? And to do this, it helps to talk first about the same origin policy, which exists for security reasons. So just in general, it's much safer to restrict read access to your web server to the same origin rather than open it up to the entire world. Opening it up may have unintended consequences. Maybe an attacker can gain access to some private data. And so it's, in general, just you want to restrict the access to only who needs it. The problem with the same origin policy is that it's restricting. So the reason why CORS exists, or one of the reasons, is that it lets you get around it in a controlled manner. So CORS lets you say, okay, I know by default only the same origin can read resources, but I also want to let origin A and origin B read resources as well. A key thing CORS does not do is prevent CSRF attacks, or cross-site request forgery attacks. So you should not use it as some blanket security policy. There are two reasons why you shouldn't use CORS to prevent CSRF attacks. So the first is that CORS only applies to browsers. So this means that native apps don't need to respect the CORS response headers. And as an example of this, you can try curling some endpoint which sends back the CORS response headers and see that even if you set the origin and the request headers to something totally random, you'll still be able to read the response data using curl. And the second reason is that CORS does not prevent requests from being sent and processed unless the pre-flight mechanism is taking place. It usually, for a simple request, just prevents the response from being read. And so this still would leave you open to vulnerabilities where some other site makes a bunch of requests to your endpoints, and they're received and processed, and that could have unintended consequences like writing a bunch of data that you didn't want to. One last quick note before I go, all the source code that I used in this video is available at this GitHub repo, which I'll link in the description. And so you can come here and check out the code, and if you want to actually run the example on your computer, it's pretty easy. You just follow these commands. So yeah, I hope you guys find this useful.